كده يعني. 休息。驾驶南方以防它广泛方向。休慢，下不了顶的，靠个顶。
没钱，你在开玩笑呀！我操！
想想是那个地方的，他这不是休假呀？这今天
Hello, everyone. Sorry for the delay. Let me quickly open my demonstration. Yeah, just feel free if you have any questions. You can post it on the chat, and I will do some demonstration later. Yes, so for the data collection, yes, for the data collection, we are going to use our device that we use in the lab and do the collection like we did. And the main problem is we need to like do the collection in multiple days across in different times. For example, you can do the collection like in this afternoon, and then tomorrow you do the same collection, maybe at the same location in the morning, and then we repeat this one for multiple times. And like, I have one question, like, what kind of device are you using? Like, is it a Mac or Raspberry Pi or Wi-Fi dongle? Yes, you can share your screen. Let me open the permission.
Hi, Rui.
And now you can share the screen.
Is my screen visible? Hi, Rui.
Yes.
Is my screen visible?
Let me check. Yeah, I can see your screen, and it's a CSV file.
Yeah. So this is the filtered data. I've filtered it for the retransmission packets, and the most of the data which we are getting are QoS and some are probe packets. So majority of the packets are QoS data. Is this data good? Like I'm not sure. Like is this get data good or not? And this is all
Yeah.
collected for 5 gigahertz.
Yeah. Just one thing to be mentioned. Like we are going to have a look of the 2.4 gigahertz. So 5 gigahertz maybe not, but you can use this one as additional analysis. But we are requiring for like 2.4 gigahertz data.
So thing is that I have the Raspberry Pi, but it is not properly set up. Like I am unable to collect on it. So I'm collecting the data from my friend's MacBook. And thing
Yeah.
is that I don't know much about the Mac OS. So what I generally do, uh, open the packet sniffer and collect, like mention the channel and the megahertz, and then we do it. So university Wi-Fi is 5 gigahertz by default. So where we can
Uh,
find 2.4 gigahertz Wi-Fi, like how to
yes.
collect?
Yes. So like if you are using Mac, you can select the channel in the sniffer. So when you open the like Mac, you need to go to the setting in the like wireless diagnostics, right? To open the
Yeah,
monitor. And then in that window, you can see you need to select the channel, right?
yeah. So channel, let's say it's on channel 50 and it's on 20 megahertz. When you
Yeah.
open the information about that Wi-Fi, it shows the channel and the megahertz. So I
Yeah.
usually choose that, but that is 5
Uh,
gigahertz by default. So
yes. Yes.
how you
So
collect for the 2.4?
yeah, you just manually change the setting in the sniffer window.
Okay.
Just select the channel like from 1 to 12, then you will automatically go to the 2.4 gigahertz. And we have the command line to change the channel as well. So because we are going to collect the data from channel 1 to channel 12, which means we need to manually
Channel 1 to
change.
12.
Yes. So which means
Okay.
we need to change the channel by ourselves manually if you are using a Mac, which takes lots of time, right? So
Alright.
I have a script that I can show you later that can automatically switch the channel. So we don't need to switch them manually.
Okay. So just that I use just 50 and 100 channels. That's why I guess it's an issue.
Yeah.
So all of the data which I'm having is like incorrect.
Yeah.
Okay. Sure. Thank you.
Yeah, all good. Let me have a check. Another question is about the data volume. So a lot of us we have some concern about do I have enough data? So usually we cannot tell you a number, exactly number that you need to collect because we are going to use the machine learning to train our data, which means we need to have a look of the accuracy between like the difference between the accuracy and the data volume. So in theory, if we have more data than we feed to the machine learning model, then we will usually have higher accuracy. So you can plot a graph, which is also specified in our specification of the assignment. So have a look of it. And we need to plot a curve that is talking about the accuracy and the data volume. So you can know if you have enough data or not.
Hi, Rui.
Hello?
Yeah. So I was asking, is 100K to 200K retransmitted packets enough for the machine learning per pickup file?
Excuse me? What I can't hear.
Am I audible now?
Yes?
Yeah. So I was asking, is 100K to 200K retransmitted packets enough per pickup file?
Yes, just like I mentioned before, the data volume, we need to have a check by training our machine learning model. So usually it sounds good, like 100K, like sounds quite sufficient because if you have a look of the retransmission rate, it's around 2% to 6%.
Okay. So issue with me was that I collected the data at the flexi week, so it was taking around 40 to 50 minutes for just 40,000 retransmitted packets. But when I'm collecting now, it goes around 200K in just 30 minutes.
Yeah, sounds good.
Yeah.
Just one thing, so we usually don't worry too much about the data volume because, so firstly, maybe you in your report you can write down a table like how many times did you collect the data, like in which day, which time, for how many duration, and for each channel, how many data do you have, and also analyze the like components in your data collection, such as how many retransmission data and how many access points did you see?
All right.
And
And about the locations, so let's say I've selected two locations and five uh, like pickup files for each location is enough, or do I need more?
so the location, I remember we specified we need to have at least 2 locations, right?
Yeah.
Yeah, so
And
we need to select 2 different location, and when you choose a location, just make sure you have lots of traffic, like network traffic over there, that you can
All right.
gather a lot of packets. So my recommendation is like the first one is the CSE building in UNSW. Another one is the library, including the main library and law library. We can see a lot of retransmission packet over there.
Yeah, I collected one in Ainsworth building and another one in computer science and engineering building near the garden, near the lawn. So 5 PCAP files per location, is that enough? Like when we asked
Yes.
it to a tutor, he was like, I'm not
Yeah.
sure.
Yes, just at least 2 different locations, and just make sure you have lots of packets in that location. So maybe you can do a small experiment by comparing 2 different locations. For example, you can go to one of the building in the UNSW or just at your home, and then another one is your choose location. So you can see the difference on the traffic like in that environment. So you can do a small comparison and put it in your report to show the location you chose is the right one.
Sure, we'll do that. Thank you.
Yeah. And another question is the Adforum 255. When you select channel 1, automatically select channel 1 at 6 gigahertz. Oh, so it's a Mac problem, right?
Yes, it's Mike's problem.
So 6 gigahertz. The channel 1 at 6 gigahertz. Maybe if you can show it. Like, or you can like do a recording or something and upload to the Adforum. So I will have a look of it.
I post on the on ED, yeah.
Yeah, you already posted. Just need to have a look of the like what is the model of your Mac. Maybe you are using the newest one, and may have this kind of issue.
Yes, I searched some results that maybe MacBook 3 has this problem.
MacBook 3. So you are using the M3 chips.
Yes.
I see. And like what is the system version?
System.
Is it Solana or something?
Sorry, maybe I don't know.
Yeah, just click the upper left side. You have an Apple icon. When you click, you can see the about this Mac. Then you can see the version of your Mac.
Mac OS 40.4 this version.
Can you take a screenshot and send it to the chat? And I think this might be because of the like newest Mac problem. I am investigating this. So if it's possible, maybe next week you can come to the lab as well, because I am using an old Mac which does not have this problem. So I have some command that I want to have a try in your computer.
Okay.
Like my lab is on Tuesday and Thursday, usually from 11 or 1 p.m. 11
Yeah.
a.m. and
Yeah, this
1
week
p.m.
I tried to find you, but maybe you don't in person come here.
Yeah. So this week I'm not in campus, but from next week I will.
So can I just use 2 channels 6 and 11 because other channels maybe I don't have enough data because I can't use one channel.
Yeah.
Oh, two channels enough.
So,
Yeah.
so in here, in this case, maybe yeah, the channel 1 is how it's okay. So you just collect the other channels at first. So I think it's okay. Maybe you can, if finally we can't solve this problem, we will take a note and announce to all our
Yeah.
tutors. So there will have no penalty on this part, but because you can still finish most of the channel, which is fine.
Yeah, because my mic only 6 and 11 are stable and other channel not stable.
That's okay. That's okay. But I will help you to solve this problem as soon as possible. Just maybe
Tuesday I go to your lab.
I will have a look of the app for that first. Maybe you can come as well if we didn't solve this problem.
Okay, thank you.
Yeah, no problem. And another message is about, is it possible to use 5 gigahertz channel to finish this assignment? And there is a mentor reply, we can use 5 gigahertz. Okay, so if your tutor is agree, so what are you going to do is, if you are planning to like do the data collection in 5 gigahertz, you can go ahead, but you need to get approval from your tutor. So you need to know like who is your tutor at first, and then you maybe send an email or just go to the lab and talk to your tutor and
Okay.
ask him if it's okay to do the 5 gigahertz. So usually it's fine, but just notice that like 5 gigahertz, we have lots of channels which may takes more time to do this part of job. So I recommend to do still within the 2.4 gigahertz.
Okay. I know. Thank you.
Yeah, welcome. And just give me like 4 to 5 minutes. I'm setting up my computer. So have a quick demonstration on the data collection and other specification stuff. But you can feel free to ask any question if you have. Just give me a few minutes. Yes, don't worry, we will have this recording available. Yeah, because now I don't have a Mac to do the demonstration on how to switching the channels automatically, but I can share the script if you want. Maybe I drop on the chat here. Or I can do a like another video like 2 or 3 minutes that demonstrate how to use the script to switch the channel automatically. May I ask, do we need all the channels, or do we only choose those that can provide us a lot of useful data? So yes, so usually we need to cover all the channel according to our specification, like which means from channel 1 to channel 12. But we can see most of the access points are within the range of channel 1, channel 6, and 11, right? So you still need to cover all the channels, but you can see most of the access points are in that 3 channels. So you can pay more attention on that 3. And let me share my screen to have a quick demonstration. Yeah. So now I'm using a Windows machine to do the demonstration on the data collection. Oops, the computer crashed after I run this virtual machine. Just give me a sec. I will have a double check. The requirement of the data packets, like I mentioned before, like how many data do we need, or how many retransmission packet do we use to train our data? It's not a it's just not a number. We need to plot the accuracy for your machine learning model. So maybe once you have a little bit of data, you can start training of your model and see what is the accuracy. If you keep adding more data, will the accuracy increase or not? If you see the curve does not change a lot after you add lots of data, which means you already have enough data.
Excuse me, Ray. Could you hear me?
Yes, yes.
I wanted to ask if we focus on a 2.4 gigahertz data, or just we can get 5 gigahertz data and add it together.
Just 2.4.
Okay, so we just train a model from 2.4 and all channel, is it?
Yes, correct.
Okay, thank you.
Okay. So let me. Just give me a sec. I'm trying to turn on my Kali because sometimes it will crash. I will have a test. And for the retransmission packet, if you barely see the retransmission packet, does it mean you are collecting some 5 gigahertz data, or the collection rate is very low for your Wi-Fi adapter or Raspberry Pi? So I'm not pretty sure why you have just a little bit of retransmission packets, but maybe you can share more details to me. So what's next? Because my machines keep crashing, and I will maybe go to the specification. And also, I have a recording for the
data collection as well. So I can share to you right now. Just stop wasting time. No. So can you see my screen in here? Yeah, should be able to see. And like so as you can see, we have multiple steps. I will just highlight them what where are we talking about. And like for the data collection, basically just like the thing we need to do in the labs, we are going to collect all the data in 2.4 gigahertz instead of any device that can collect all the data, like which have the Wi-Fi dongle available, or you can use your Mac or Raspberry Pi. Should all work. And if you, let me know if you have any question about the devices. But and I have another recording in here. Is using the Wi-Fi adapter. This one, how to install the Kali in your Windows machine, just in case you have some trouble in how to use the Wi-Fi dongles in your Windows machine. So basically in here, I plug this Wi-Fi dongle in my computer and launch this one in my Kali system in my Windows machine and start the data collection in Wireshark. So this is a video. I will share the link to you so you can have a look if you are interested. Why is the network adapter unable to collect the retransmission signals? Maybe you need to have a check. How did you collect the data? Did you enter in the correct monitor mode? And why you don't have any retransmission signals? Let me open one of my files. For example, this is the file I collected before. So you can see a lot of information in one of the packets. And then, so because we are going to use this kind of data to train our model, right? So we are going to select part of the data and put it into our machine learning model. But for the machine learning model, I will explain it and have a quick demonstration next week. But this week, we are going to focus on the data collection. So you might have the similar data collection like this. So what's the next step are you going to do in here? So firstly, you need to have a check. Did you have any like retransmitted data? So you can see I apply a column here, retry, which means it will show like, is this a retransmission data or not? So you can see around 3% of the data has been retransmitted, and some of them are the probe response, and some of them are QoS data. And because the collection for this file is very short, the time duration is very short, so I didn't have enough data to show you, but you may have a lot of this kind of data in your collection. And what's next is you need to apply correct columns in here. And for example, we can look at the parameters inside. Then you can see a lot of useful information. For example, what is the sender and receiver, and what is the SSID? Like, for example, this is the SSID. We might need to apply as a column in here. So in the future, when you put it into your machine learning model, it can be considered as one of the features. And what else is maybe the channel, because in here we usually collect one of the channel, and the transmit power might also help you to change the model. So maybe I need to have a check of what is the channel number of this stuff as well. So for this file is only for channel 1. Channel 1 in most of the case, but I try to switch my channel like into 2 and 12. But like in here, I can see the retransmission packets are focusing on those channels. So maybe we can also plot a distribution of those retransmission packets features. And you need to have a look of the packet inside, like by have a check of all the tags in here or headers inside. So just try to include more information in your windows here. And then next step is we are going to like maybe save it as a CSV file like we did in lab 2. And this is exported as a CSV file. So as we can see, the protocol is definitely not help us to do the machine learning model. So maybe we can remove this one. And the source and destination might help. And the time usually does not be very helpful in here, and the number as well. But in here, another thing is we are also going to like calculate what is the acknowledgement time, right? If you go to the specification of the data collection or analysis, like we need to know how many times about the retransmission and what is the net latency in here. So how can we calculate those stuff? I will just have a quick look in here to show you how to then see what is the latency we calculated. And next week, I will maybe show you some script to calculate them automatically. So for now, if we want to know what is the latency of SSID, how are we going to do? Maybe we can focus on one of the APs right now. Let me check if we have any acknowledgement packets here. So acknowledgement. This one, acknowledgement, but how can we see, like, what is this acknowledging? Because as you can see in this packet, we do not have any source from the sender, right? And we only have a destination in here. So how can we find what is this packet acknowledging? Maybe you need to have a check in the lecture slides. But in here, I will have a quick demonstration of how it works. So let's say we have lots of, like, maybe we call it AP1, AP2, and we have AP3, and IN1. For example, this is the, like, your surrounding environment, and you are the circle. You are the circle like this. Yeah. And this is your sniffer. So if you are sniffing the, like, you are sniffing the traffic between these two, then you can see all the communication from the client 1 to access point 1, right? And in this case, let's say we have another client 2 with the access point 1, and you will not be able to see what is the content from client 2 to access point 1 in here. So you need to be aware of that your sniffing content, your sniffing data may not be completed when you have a look of the latency and try to calculate the latency of the access point or their communication. Because you might only see a part of the conversation between the access point and the client. And for example, in another case, the client 1 is in your sniffing range, but it is talking about the access point 3, which is out of your detection range. So you will not be able to see any response from access point 3 to client 1. So to this one, you will not be able to see. And for the data from client 1 to access point 3, you will be able to see. Does it make sense? And after you understand this, then we can have a look of the transmission here. So the first one we had a look is about the acknowledgement in here. So the destination is this one. So we need to see where did this, like, access point or client send the previous data. We might need to have a check in the previous columns, previous rows. Do we see this address in the source or destination? So we cannot find it, right? Which means we only hear a part of this conversation. So we do not know what is this acknowledgement replying. to which packet. So maybe we can drop this one at first and have a look of this one, the Samsung. So the same rules. So we are looking for the Samsung like ending by F840. F840 we can't see, so we still do not know this case. So in here is just something like this case. So we can just see the part of the conversation, but we cannot know what is the latency of this conversation because we lose part of the information. So we can keep going, see if we can check any other acknowledgement here. AMP. And we might want to use a filter like this. So what is the MAC address? This one. So apply as a filter. So the receiver is this one. We can see a lot of acknowledgement. So we want to have a check if they send any packets. Source and destination. Yeah, so in this access point, we are not able to see any conversation because we just get part of it. So what you're going to do is you are going to replace this address to see if you can find any like complete conversation between the client access point and then calculate the latency. So try another one. Yeah, and as you can see, we can see part of the conversation and most of them are missing. We can only see the acknowledgement, but this one, they might be a pair of it. So in this case, we can see like the latency is around 0.1 seconds. And also this one. So usually the acknowledgement is acknowledged a like data transmission or other stuff. So you need to match them and calculate the time difference to see the latency. Is that okay? So maybe next week I can bring you some script or a notebook to show you how can we do this kind of calculation automatically. So, but you need to understand how it works and how do we calculate the latency at first, so you can write into a code and make it work. But like this week, we are going to focus on the like data collection mainly, because I know most of us haven't started yet. So I'm not going to talk a lot about the analysis right now. And just let me know if you have any trouble on the data collection at first. And the Mac computer doesn't seem to have the retry column. I don't think so. I think you will have this retry column because I add this column by myself. So usually you will look something like this. Your Wireshark maybe now it's looked like this. And then you need to click into one of the packets. And then in this window, you can find like what is the type of the packets and is this a retransmission package? I remember it's in here, right? Frame is not being retransmitted. So you just right click, apply as a column, then you will have this column. And please also let me know if you want me to demonstrate anything. Because today we are mainly focused on the data collection and it seems the major question is about the data volume. So what I recommend is you are going to spend around like 20 hours on the whole assignment, including the data collection and the processing and machine learning and report writing. And that should be sufficient. Which means you may take like couple hours on the data collection in different days and different weeks. So you don't need to collect a lot in a single day, but if you can do that, that's definitely better. But just in case you don't have enough time, maybe like you can bring your computer to our library or to the CSE building, which we have lots of computer running over there and doing a lot of transmission between the routers. And then you can see lots of retransmission packet as well. So you just like sit there and open your own program to do the collection. And then you will get sufficient of data. And you just repeat it for multiple days or multiple weeks. Then definitely will be enough. So usually we spend like two weeks on the data collection. Like every week you spend like 1 or 2 days. But it doesn't mean you need to like working on it for a very long time. You just need to have the data collected. Yes, can the data collection time being different? That's totally okay. And it might be better actually. So you collect the data like in the morning, and then next time you collect it in the afternoon or midnight, then you can see the difference between times in the same location. So we recommend do it in different times. Yeah, so like what I recommend is to have a look of the marking rubric. So for the data collection, you can see at least 2 different locations. So my recommendation is maybe you can have a try of, let's say, 4 different locations, and you choose 2 of them as your main locations. And for other 2 locations, you don't need to have a lot of data, but you can just simply comparing different locations, like what is the data volume like per minute for different location and why you choose these 2 locations. So that may definitely help you to have excellence in your data collection in here. And you can see like day and night. And spending different hours, which means you collect the data in the same location across in different times, like in the morning, afternoon, or if possible, midnight, but it's not compulsory. So you can see what is difference in the same location. Because the access point is not moving, but the client is moving. So you can see what is the difference in different times. And for the data analysis, so basically we want you to have visualizations in your report. So maybe next week I bring you a Jupyter notebook that can show you some visualization we are looking for, and also like some basic procedures of how are you going to like process your data. For example, you will have some data like this. So we are not going to look into details of your submitted file like this because it's very large file, right? Usually we have more than 100,000 packets collected. So what are we going to do is, so you need to firstly filter out the useful information here. Maybe the protocol is not helpful in here, and the length may help, and the frame number may be not very helpful in here. Frame number, and the retry maybe yes, and the type of the packet, I think so, and the SSID, current channel, what is the channel of the packets, right? So those are the useful information in here, and you can discover more information in here and apply as a column in your data set. For example, if you think one of the tag is useful, like which one? Let's say the duration, apply as a column. The duration of the packets. You think this column is useful, then you apply as a column, and at last you will export this file as a CSV file like this. So we can use it for later usage in your machine learning. So if you have zero knowledge in the machine learning, don't worry too much, because for our machine learning, it's very, very simple. I will just go back to here. Let's see what are we going to do with the machine learning part. Basically, we have already give you some model you are going to use. So there are 3 different models, right? KNN, Random Forest, SVM. They are really well-known models. So you don't need to code it by yourself actually for those models. But one thing you need to do is just go to the scikit-learn documentation and see how are we going to use those models. Let's say the classification. maybe can have a quick look of those kind of models. Do we have some demo coding here? I think so, but it's not showing up in here. You can just have a look of how it works. So usually we can use this Python library in just less than 10 lines to train your model. So basically, I would say maybe around 30 minutes to 1 hour, you will get your model ready. Once you know how to use it, it's extremely simple and easy to use. So you are not going to spend lots of time in this part. The only thing you need to do is get your data prepared, and also you need to take care of the features. So what is the features? The feature is like a column like this. So including the channel number, or could be the length of the packets, right? And also could be the access point. So what is the access point's name and like SSID? So for example, this one, we know it is not stable for this access point. So it can definitely help us. It's likely to have retransmission packets by using your machine learning model. So what are you going to do is you are going to select your own columns for the table and put it into the machine learning model, and it will report the accuracy on the prediction to you. For this one, you don't need to worry too much. We are going to show you as well. So we will have a short demonstration maybe next week as well to help you to understand what are we going to do in this assignment. When we submit the collected data, do we submit it as a CSV file or PCA PNG? In here, do we say what kind of data are we going to submit? No. I recommend just to submit the CSV file, easier. And also maybe get your like the raw data ready. But to be honest, we are not going to check your submitted data line by line because it's lots of data. We are going to see how are you going to proceed with your data and do some visualization. So what I recommend is you can submit your data set in CSV file and make it a zip file as well. Just put different CSV together, or you can just make one CSV file and you manually label them. And original file you can like upload to your Google Drive and do not touch them after the submission deadline. So you can keep the like evidence of your submitted data. But usually we don't have this kind of issues. And I think like most of your time will be invested into the data collection part. This part requires you go to like different crowded location and do the collection. And another one is the protocols and design your own protocol or enhancement rules. So spend more time on the part 1 and part 4. And part 2 and part 3, I will have some demonstration next week. So you don't need to worry too much. And if possible, also talk to your tutor, like of your progression. Like, for example, you collect some data, and but you have some doubts, like if I have enough data or if I did the collection right, maybe you can bring the stuff to your tutor and ask them if this is okay, and ask for advice or suggestion. So you can get more feedbacks because your assignment will be revised by your tutor. So if he or she feels okay, then it's definitely okay. And also, like, if you cannot go to the lab and you have any question, like, feel free to come to the help session. We will have another 2 help session. The next one is on next Monday, and maybe weeknight Monday as well. You can bring any question about the assignment to here, and I will help. If I will do my best to help you. And also, if you cannot come to the next session, you can also post your question on into the ad forum. Yeah, and like feel free to about the data volume. So because we have lots of question about the data volume, so most of you are worrying about what if we don't have enough data volume. So firstly, you don't need to worry too much if you spend enough time on the data collection. And the next one is I'm going to tell how are you going to have enough data volume. So after you collect the data, so you have no idea like if it's sufficient until you go to the step 3, which is the machine learning part, right? So in the machine learning part, you are going to produce a graph like this. So in here, you have like 6 different models. So you can see an uptrend in here. Like, like so in the x-axis is the data volume, right? We are going to use it for the training. And then the y-axis is the accuracy. This means higher accuracy. So this is 95% and this is 80% of accuracy. So, and then you can see an uptrend for some of the models. For example, this one. So if we are only have like 10,000 of the data, it will have lower accuracy. But if we feed more data, let's say we feed the 50K of the data, you can see we have higher accuracy in here. So it's an uptrend in here. And then after we have like 100Ks, we have around 87%. So you can see it's a curve like this. So for this machine learning model, like how many data is sufficient? We would say it's around maybe this area, right? 80K or 90K of data. So you can see in your data collection, you will do the same thing. So you're going to collect the data. Let's say you collect 100K of data, and then you will plot the accuracy versus the data volume for training. So you can see a curve similar to this. After you see this curve, then you will be able to know how many data are model. I would say around 85,000 should be sufficient. Or you could say maybe 70,000. So around this area. And we can see the same for the other models. For some of the model, maybe it only requires a little bit of the data. For example, this one, at when we have 10K of data, we have very high accuracy. And if you feed more data, it will just like a flat line here. So it doesn't change a lot. So we will say in this point, we already have the sufficient of data. Does this make sense? You only collect one channel data. That's fine. Yeah, but also try to cover like different channels. So you just consider you have additional data for that channel. It will be helpful. But I recommend to have like different channels in different days, in different locations. So if you are using a Mac, I recommend to have a script on how to like automatically switching the channels. Yeah, by the way, I need to close the script here. Yeah, if you are using a Mac, maybe you can try this kind of code I sent in the chat. You can simply copy this one. So with the data collection for your Mac, because we need to select the channel, right, in the sniffer, and it's taking time to manually change them. So in here, I have a script that can help us to switch the channels automatically when you do the collection with your Wireshark. And when you're doing the collection, you just run this script. So save this one as a file and use the bash command to run it. And it will automatically change the channel from channel 1 to channel 6 and channel 11. Basically, you can add more channels here. I will also post this one in the ad forum, so you can have a check. Yes, one question about the machine learning. Since we need to train a model to predict the likelihood of packet transmission, do we still need some data that's not be retransmitted? Yeah, definitely. Because when you do the data collection, I can see like most of the data is not retransmission data, right? It's just normal packets without retransmission. So you want to feed the whole data set into your machine learning model, or maybe you can do some filtering. Depends on your like pre-processing procedures, but I recommend to put the whole data set with the correct features. Like the percentage or likelihood of retransmission. Then if you do not give the packet that is not retransmission, then how the machine learning model can see the percentage of the retransmission rate? Yeah, and it also depends on the model you are using. For example, you are using a linear regression model, which means it will basically do the math calculation, like how many percentage of the packet will be retransmitted by maybe group by SSID or group by other kind of features. So those kind of information will be required. How can we calculate the channel utilization? Let me check. If you had a look of the graph like this, let me quickly show you a graph. Like if you have this kind of like Wi-Fi analyzer in your mobile phone, you can have a look of this kind of graph. It will show the ISSI as well as the frequency coverage. So, for example, the yellow one is the access point in channel 6 in 2.4 gigahertz. So this kind of is a like visualization analysis. So you can have more visualization like this. So we can see like in channel 6, we have 3 APs. And in channel 1, we have like 1 or 2, you can say 2. And channel 13 have only 1, and etc. So in this case, like we can say maybe channel 13 is ideal for Wi-Fi. Yeah, just let me know if you have any other question. I will stop sharing my screen. And if you have any trouble, you can share a screen or post your question into the chat.
Probably around that, actually. It's probably around